Welcome to the introduction of LVM Enterprise AXI Verification IP. The UEVM compatible VIP has been coded to be robust, reusable, measurable, systematic, and efficient, with easy debugability and user-friendly features. Our objectives are to help creating various stimulus with ease and minimal codes, to shorten the time to bring up UVM test bench with RAW, to provide users with high-quality industry-standard protocol checkers, to create an ideal platform for novice UVM users, and finally, to provide a low-cost solution for verification in the industry. The VIP operates in an XI protocol with 5 channels, which are write address, write data, write response, read address, and read response. Here shows the example of VIP integration in the base test, where it is connected to any base virtual sequence with a handle of the VIP. Besides, the connection between rail and user scoreboard can be done in the connect phase of base test. After that, all the child test and child virtual sequence can have access on VIP instance. On the other hand, module top instantiate the VIP interfaces and also the protocol checker alongside with design under test. Let's take a look at the VIP strengths. User-friendly. Our VIP simplified the steps to integrate and configure to the max, and it is proven to be simpler than any other vendor. All the steps are demonstrated in the self-verification test bench. Besides, user can configure different protocol or signal width per instance. During the runtime, user can easily turn on or off components on the fly. In addition, engineers just need to instantiate the UVC without doing anything on config class, sequence, sequencer, adapter, predictor, and so on. Driving part. Our rail predictor and adapter are already built, in with connection syntax. The adapter supports partial and full register access for 8, 16, and 32 bits accesses. For predictor, it works for burst packets and partial accesses packets. In terms of driving stimulus, our VIP sends in fully pipeline mode by default. It is done by just calling the API. For example, sending a write transactions can have write address channel comes first, write data comes first, write data comes first, or both of them come concurrently. Moreover, parallel write and read packets, packets waiting, ready signal and power signal driving are all done via API 2. Most API can be done in one line of code. Full examples can be found at self-verification test bench as well. The VIP supports X injection for window outside setup and hold time. This feature can be easily configured and can be turned off too. As stimulus is mostly done using a PI, the code is very reuse-friendly, where just the VIP handle is needed. Examples here showing configuration, write and read, a PI. In terms of extracting the packet information from VIP monitor, the full code for sequence item retrieval for all info needed is already part of example, user scoreboard. They are useful to help user to code the higher level test bench scoreboard. Monitoring part. To ease user to track the packet in the log file, VIP dumps the info with full details. For example, at the tracker here, you can see that this is a 5 beats of 1 byte write and corresponding address that get written with the effective data. Each beat is annotated with the effective data bit positions, write strobe, and its impact. At the end of simulation, user can see each data inside the memory for the addresses that get exercised. In addition, it prints the statistic of total write and read packets and total check triggered on read. Checking part. ARM Protocol Checker is embedded into VIP with further enhancements. Any error flagged will be in LVM error. The automated memory checking is embedded inside our scoreboard, where effective writes within user-defined memory range will be keep tracked as new data, while all reads within memory range will check data matching expectation per last written data. In case the packet address is out of valid address range, the scoreboard will ensure correct B response being returned. They can be decode error or slave error. Same for read packet. The R response will be checked against user-defined expected response. VIP will gate the simulation if there is still pending B response or R response. This ensures the slave is able to respond to all accesses correctly. Debug part. To ease the user to understand the transaction easily, VIP prepares a lot of enum signals. This includes burst, lock, cache, prot, and size of write address channels. Besides, user can easily see the effective address targeted by final write data and its write ID, as shown by yellow signals. Moreover, the purple signals annotate the address and response for the B channel. Same for read address channel. VIP provides the enum signals too. For R channel, two helpful signals are data's corresponding address, its size, and response. Test suite. Our test suite helps to verify every channel outstanding depth and also the response of every packet to meet expected value. Meanwhile, the data integrity of the design is verified with full blast of randomized AXI packets, with and without all types of B-ready and R-ready conditions for stressing slaves or interconnect. Performance Analyzer. At the end of the log, user can analyze the bus utilization percentage and the slave performance by measuring the total wait clocks. Partial register access verification. UVM bit bashing sequence only verifies the register access in register data width. For example, when user registers are in 32 bits width, the packet sent will be in 32 bits. To complement that, VIP adds partial register access verification. Example, here shows byte access of 32 bits register, where it can be byte 0, 1, 2, or 3. Same for half-word access, where it can be lower 16 bits or upper 16 bits access. Burst register access verification. UVM bit bashing just verifies on single access. For burst access on register, VIP will randomize the total byte per beats and total beats per packet. For write, it will make sure programming is successful after considering fields whether is read-write, read-only, and so on. For read, each burst return data is checked against expected data. An example below, 4 burst packets in 1 byte can program all the 6 registers in 32 bits. Our VIPs are striving for the best quality in the industry. It is not only user-friendly, robust, high debugability, reusable, easy to integrate, lightweight, reset-aware, and also comes with various features like strong and strict checker, comprehensive protocol test suite, register burst, and partial accesses and X injections. Thank you very much for your time. Please do not hesitate to contact our email here to get a copy of VIP